soldering iron, I'm bringing up the temp to 700 degrees because solder flows well at that temperature. I mean, the melting point is about 400 degrees Fahrenheit, but you'd be soldering with a gel. So you want to be soldering at 700 degrees Fahrenheit again. Okay, so here I have, guys, the balance cable that I was working with on week 2, I think. And if you remember, I prepped one side of the cable. Here's my ground conductor. Here is signal conductor number 1, signal conductor number 2, and you see that the tips are silvery. That's because I've already tinned those tips, and these are ready to connect onto a connector. This side has not been prepped. Well, wait a second. Well, this side needs to be re-prepped because the ground cable here has been tinned, but signal number 1 and signal number 2 have not been tinned. So let's start with this side. All right, and again, I'm building a TRS male to XLR male adapter cable. Let me go ahead and trim these a little bit. All right. I think that these are about 20 gauge internal cables, so I'm gonna take my wire stripper and let me see if it's 20 gauge here. No, it's smaller than that. Okay. Oh no, it's thicker than 20 gauge. It's 18 gauge. In as far as gauge numbers are concerned, guys, the larger the number, the thinner the cable. So this is an unusual, actually this is an unusual balanced audio cable. Usually the internal cables on balanced audio are 20 to 22 gauge. I bought a spool of this, like 100, no, it wasn't 100 feet. It was like 500 feet of balanced cable because I needed to make cable for a live sound reinforcement thing that I was doing. I needed to run long cable runs. Now, I didn't run 500 feet of cable. I mean, I made a few, I made like 5 100-foot cables with this. Actually, my students at the time, made them. But anyway, regular balanced audio cables have internal cables that are about 20, 22 gauge. This is a little thicker. These are internal 18 gauge wires. The thicker your cable, the more signal integrity you have when you have long cable runs. I may have problems getting the housing of this. I think what I did, because I bought regular XLR cables with regular housing on them, is that I had to cut into the housing in order to thread it through this thicker cable. But if you guys buy regular balanced XLR cables with the internal gauge of the cables being 20 to 22 gauge, you won't have to mess with the housing of your XLR to thread it through. Actually, let me do that now. I always, something I forget to do and I have to remake the cables often is I forget to thread the housing through. So let me go ahead and do that. So I'm going to use this as a TRS end. I'll use this as the XLR end. So I'll thread this guy through as best as I can. And there it is. Okay. Cool beans. Now let me thread this other guy through so I don't forget. Because I often do forget. Okay, housing threaded through. So now I know which side is going to be my XLR side and which one is going to be my TRS side. Okay. And I've gotten a feel for how far to cut into the cable. All right, there we go. Stripped. Now take those copper bits and twist them. Okay, now we're going to strip conductor number 2. All right, there we go. Yep, trusty wire cutters. For me, they're easier to use than the actual wire strippers. All right, and I'm going to twist the copper flecks that are there. All right, next thing, I gotta tin the tips, meaning I gotta apply solder to the copper that I've exposed. I've already got a tinned ground wire. Let me tin the tips of these guys here. So first, I'm going to dip these guys into the flux. Don't use a lot. Don't use a lot. This helps your solder to stick without heating up the elements too much. I don't want to burn through my conductors. I just want to heat them up. And if you can get your solder to stick without having the iron heating these guys, having the iron on these guys for too long, that's ideal. All right, okay. All right, I'm gonna use my trusty helping hands here. Oh, why did you do that? I'll crimp that back on later. I don't know, things are falling apart for me these days. My microphone fell off its stand this morning, and my helping hand just lost a hand. Goodness gracious. It's easy to fix. I just gotta crimp it back on. All right. All right. So I'm gonna grab conductor number 1, and I'm going to. I'm gonna tin this thing. Let me see if I can. Yes. All right. All right. I'm going to apply some solder to the tip of my iron. Right now it's reheating up again. It went into sleep mode. I have a, it's not a smart iron. It's not connected to the internet or anything, but it has this mechanism, this sensor that if it feels it's getting too hot and you're not using it, it'll go into sleep mode and lower the temperature on you. So it's back up to 700 degrees. And I'm going to just apply some solder to the tip and then dip it into my Brillo pad and have a nice shiny tip. You need to do this before you heat up your wire here. All right, so heating up, heating up, heating up. Let's see if it'll stick. All right, we got a tinned tip. That's it. All right, we're gonna switch conductors and we're gonna tin the remaining tip. Angel, you're laughing at me. Why? Yeah, I know. I know why. I'm just in denial. Okay, here we go. We're gonna tin the next tip. All right, I'm gonna heat this up a little bit. Heat it up, heat it up, heat it up. Heat it up, and let's see if it'll stick now. And it does. It's that easy, guys. There we go. Okay. Now, let's start with the TS side. I've prepped the cable. Now I have to prep the connector. I gotta tin the tips on my connector. First, oh, it looks like I've used this connector before. Let me clean up the, this looks like I've already had solder on these connectors. Let me clean up the solder a bit and then consider it tinned. All right. I don't like the globs of solder that I see on this connector, so I'm gonna try to remove some. Heating up the conductors and just removing some of that solder that is not necessary. You don't need huge globs of solder to get things to stick on. This could have been one of my early connectors when I was working with a soldering iron that did not have temp control. And again, if you're working with a soldering iron that does not have temp control, you're not going to get it up to 700 degrees. It was probably close to the melting point of the solder itself. And again, in that case, I was soldering with a gel, and when you solder with a gel, it's extremely hard to get things to stick to your connectors. All right, so Helping Hands is holding my conductor, which I'm going to clean up just a little bit. I'm going to reapply some flux, and then get things going here. Oh, come on. Wait a second. Helping Hands is not holding things tightly enough for me. Come on, Helping Hands. Be helpful. All right. All right. Again, I'm just cleaning up the solder on these pre-tinned connectors. I'm working with the signal conductor now. Let me get my fan to blow the smoke away from me. There we go. Okay, got some solder off of that. Smoothing it out a bit. There we go. Same thing with the ground here. Too much solder here. Oh. Helping Hands is not holding things stiffly enough. Let's get this really stiff there. All right. Cleaning up the solder here. Might have to heat this element a little. Why does that look burnt on? Okay. No, I'm able to smooth it out here. Good. Awesome. Okay. Okay, so I got... Let me remove that from the ground. Got the ground fixed. Where did I put... Doesn't seem like I put any globs of solder onto the to conductor number 2. It looks like I still have to tin conductor number 2, so I'll go ahead and do that. Again, let me check here before I touch this. Okay, it's cool to the touch, so I can go ahead and use my fingers to apply some flux to the conductor that isn't tinned. Again, I'm applying flux to the conductor that is not tinned. All right. And I'm gonna go ahead and heat up the element a bit. Let me get some silvery stuff back onto my soldering iron. You always want to solder with an iron that has a silvery tip. And let me go ahead and heat my conductor before I try to apply solder to it. And let's see if it'll stick now. All right, that has been tinned. Okay. We've got tinned conductors. So I tinned, this is the ground plank, and the bottom part of that plank has been tinned. Here is the short conductor, which is conductor number 1. That has been tinned on the inside, as you can see. And then conductor number 2 has been tinned on the inside as well. Okay. And so now, this is ready to be connected to my wire. There we go. Some flux. And maybe my connector, make sure it's, yeah. Let me bring it closer to you guys. Again, I'm re-tinning the ground conductor. we go. There we go. Just painting it on like that. Okay. Now, hopefully, it should be easy to bring them together. All right. Let me position this in a way that I could just bring the iron down on these guys and they'll come together. All right, so you're seeing the big giant painstaking process here. There we go. Thank you, helping hands. Let's see if I can apply. Okay, I can apply some pressure there. Tin this guy again. This is the longest it's taken me to make a ground connection. Yikes. Got some more help to apply some pressure on here. All right, I finally got it to stick. It's wait a few seconds before you touch the connector or the cable. What I'm gonna do now is tug on the ground cable to make sure that it is secure. If it's not secure, when you put the housing back on, it'll disconnect and you're gonna wonder why you don't have continuity between ground and ground. All right. It's okay to touch. I'm gonna disconnect it. Well, on both sides. And let's see how strong this joint is. Okay. I'm pulling on it, I'm tugging on it. I got my ground connected to my grounding plate. Now, I'm going to check for continuity, which is this guy right here. All right. All right. So this will send a low voltage through my ground conductor, and I'm going to see if my ground conductor on the other end receives the signal. And if it does, it'll give me a beep. If it doesn't, there might be something wrong with my joint, or there might be something wrong with the cable or connector itself. All right. So let's first check the joint with my ground connector on the other side, and then I'm going to check the conductor on the TS with the ground conductor on the other side. Before I check for continuity, I bring my two leads together, make sure it's working, and so I'm going to grab the ground cable on one side and touch the ground cable on the other side. Okay, we got continuity between the two cables. Let's check between continuity between the joint that I just made and the ground cable. Okay, good joint. Now let's check the conductor itself. That's the ground on the conductor. I'm going to check the ground on the other end. Okay, we got continuity on all areas that I needed to check. Now we can continue. I'm seeing a little issue here. My signal conductor isn't long enough to reach this small plank. It's not long enough to reach its corresponding conductor on the connector. So what I'm going to do is get some wire and extend the cable length a bit. And do I have the same problem with the signal copy of the signal, or wire number 2, conductor number 2? Yes, I do. So I'm going to have to make 2 extenders for these conductors. So I got to prep some other cables. I am back, and I brought out a spool of some, I think this is 18 gauge cable. You want to make sure that if you have spools of cable to use for audio applications, make sure that the internal cable is copper and not aluminum. It seems like these are aluminum. Can't use this. Let me search my little cable box and see where my copper spools are at. Yay! So these switches have copper on them. I'm going to then hack a little off of these switches, which I'm going to use later. take a little of the cable off of these switches and use them as extender cables. Okay, nice copper. Here we go. And stripped one end, I'm going to strip the other end and then prep both sides. Oh, I cut off my extender. Let me see if my wire strippers will have better luck. Let me make sure it's still the... Okay, yeah, I should be able to get it together. Still an okay length. Okay, these are not 18. Okay, this is also 18 gauge. It's too stiff for me to hold. Let me see. Okay. Okay, so I removed the sheath from both sides and I'm going to prep this extender cable the same way that I prepped the main cable. I'm going to twist the copper ends and tin each tip. Again, you won't have to do this unless you encounter the same problem that I encountered. I cut these guys too short in proportion to the ground, and so it can't reach the conductors on the connector. So I had to make extender cables again. If you buy some spool of like 18 to 22 gauge wire, make sure that this copper core and not aluminum. A lot of cables that you'll find on the... I mean, make sure that when you go to Amazon that it specifies in the description somewhere. Okay. So I'm going to tin these quickly. Got my flux. Got my iron, which went to sleep because I'm just taking too long. Here we go. Wake up, iron. Wake up. Temperature's going back up. There we go. All right. So I'm going to heat. Okay, one side is tinned. Heat. Other side is tinned. All right. Now, I'm going to get this onto my main conductor. Okay, why not do it this way? Okay. I don't want to crimp these guys together. All right, let's see if I can bring these together quick. All right. Okay. Let's get some flux on there. Help things stick faster. All right, heat. Okay, that's tinned. Now let's try to bring it together to the conductor. Okay. All right. Oh, that's nice. That's a nice fit. It just happens to lay straight onto where I want it soldered. So I'm just going to hold it like this. Oops. And bring my soldering iron down on the tinned tips of both cable and conductor. So here we go. Oh, okay. You're not going to stay up. I'm going to hold you from the bottom. All right. Okay, make sure okay, cool to the touch. Let's tug on that a little bit and make sure that it's secure. Okay, so there's the joint, guys. There's the joint. And I'm gonna pinch on it a little bit. Yeah, that's not coming off. So let's check for continuity. Here we go. So let me move helping hands out of the way just for a second. All right. Checking for continuity again. This time we're checking conductor number 2, which is the first signal conductor. Let's bring the leads together. Okay, this is ready to go. Let's go from cable to cable, here to here. Okay, now let's check the joint. Joint to red conductor here. Oh, let me get it on here. Oh, oh no. We're not getting continuity. Okay, it's conducting signal. Good. Now let's check tip to red cable here. Good. All right. Now for the last conductor on the TRS side, and once that is in place and we've checked continuity, we can roll up the housing and then check continuity again. Why do you check continuity after you roll up the housing? Well, to make sure that the circuit hasn't been broken by any of the internal conductors touching each other once the housing is back on. So if you get continuity on your TRS conductor, external TRS conductors with the other end of the cable, then this side is good to go. All right. Okay, let's see. Do I really need an extender for this side? Yes, I do. Yes, I do, unfortunately. Okay. Maybe, yeah. Okay. That's all right. Let's cut off a piece of this cable from this switch that I'm going to use later. Let's see, this much. Oh, I shouldn't have cut off so much. Oh, I'm sorry, I'm out of the video. Okay. Okay, exposed one side, twist it, and I'll cut off the other side. Let me see how much length I need. Not too much length. Not too much length is needed. And use my trusty pliers to unsheath the other side. Okay. Okay, other side has been unsheathed. Okay, let me check the length though. Checking the length. Good. It's too long. But let me at least attach one end and then I'll cut it off when it's one big cable. Okay. Let's bring helping hands back in. Oop. There we go. Using a piece of tape so this guy doesn't move around on me. Yeah, really high-tech setup. Not really. Okay. Let's apply flux to both ends of this little extender cable. Okay, flux has been applied. Let's tin the tips. Let me prep my iron again. Let's heat up this tip. And let's see if I can tin it. Okay, that side is tinned. Let's heat up this side. Okay. That side is tinned. Perfect. Now let's get it attached to the main cable here. Let's see. Let's see what the easiest way to do that. Let's bring both of these guys together. All right. I'm going to hold the cable with my hand, hold it up against where I need the connection to be made. Let me move the helping hands closer so you guys can see what I'm doing. Let me see there. Okay, let's bring the iron down on the tin tips. Oh, come on, that's not so good a connection. Come on, there we go. Okay, I'm gonna secure that a little bit more. Okay. All right. Let's tug on that for a bit. Okay, that's a secure extender. Let me pass it through there, pass it through there. Yeah, the cable is too long, so I'm going to have to do the same thing that I did to the other side, trim it. Let me see how much I have to trim. Okay. Marked it with my thumb. Okay. All right. Now I have to tin that side that I exposed. Cha-cha-cha. There we go. Let's bring some flux down on that guy. Too much flux. There we go. You don't want globs of flux. No. And let's heat up cable a bit. Heating, heating, heating. You ready to melt? Yeah. Okay, tinned. Now let's bring it together. Oh, crap. Look what just happened. What I thought was a secure connection between signal signal 1 or connector number 1 was not secure at all. Now I have to put this back together. No. Okay. How does this want to connect? Seems like this wants to connect on the outside. This is what you call reality TV, guys. It's reality. Unedited. Let's get that sorted. Get this sorted, excuse me. I'm going to tin the outside of signal number 1 conductor, just so that I can get cable number 1 to stick firmly to it. Can I get the inside though? Would have been nice to get it on the inside. But oh well. Come on, helping hands. All right. Okay, it's a little out of view. Let me bring it closer to you guys again. Conductor number 1 has decided to disconnect, so I'm gonna tin the outside of my of conductor number 1 and make a connection from the outside rather than the inside and see if that'll make it more secure. Let me bring that up a little. There we go. Okay, so I'm gonna apply a little flux to the outside here. All right, and I'm going to heat the element. Oh, has the solder stuck? It has. Okay, I just tinned the tip. I applied enough solder to my iron, and apparently I had heated it just enough for it to stick. Let me re-tin the tip here, and now let me bring that tip down onto my conductor. See if I can get it to okay, it's not hot. Bend right down and meet the conductor. All right, pushing down on that. Let's heat both guys at the same time. Okay, this looks like a secure connection. Okay, give it a moment. See, looks like a secure connection. We're gonna have to check for continuity again though. Let's tug on it a little bit to make sure that it doesn't disconnect on us again. All right. Tug, 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 tug. All right. Ground is separate. Okay, good. Let's check for continuity, guys. Again, set my multimeter to continuity. Let's check the joint. We know that conductor, well, let's not assume. We'll check again. Let's check the joint. Yay! Moving to the conductor. Yay! Okay, now let's get that second conductor number 2 going. Now, where did I tin this? I tinned this on the inside. Oh, wait. It looks like tinning on the inside. I'm gonna have to tin this on the outside because I don't want conductor number 1. I don't want to give this piece of copper a chance to touch this piece of copper because that would ruin my circuit. So I'm gonna tin the outside here. Not what was planned, but it'll solve the problem. Okay, bringing back my helping hands. All right. So let's bring some flux down on the outside of conductor number 2 right here. It's a nice amount of flux. And let's tin the very tip of that conductor. Okay. So heat, 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 heat. Okay. Nice. Okay, now let's bring conductor down onto, from the cable down onto conductor on connector. And I want to do it in a way where I'm not going to burn my hands. So, there we go. I'm going to need this guy to help me out. Bring my iron down on the joint. Okay. Let's see if that is a secure enough joint. I'm pulling on it. Good. Let's check for continuity. We're going to check the joint, and then we're going to check the corresponding conductor, and this is the ring. We're checking the ring conductor on this TRS connector. So, first of all, okay, we can make a reading. I'm grabbing the joint we just made and going to the white conductor on the other side. Yes, now we're gonna move to the ring. Yes, ladies and gentlemen, we have a working cable now. We have to roll up the housing and then we can and then we'll see if we still have a working cable. How do we check? We check for continuity. All right. Okay. Sometimes when you try to put the housing on, you'll disconnect your beautiful joints. So we want to check this. Okay. There you have it. Let's check for continuity on all the conductors, tip, ring, and sleeve. Let's do the tip, which corresponds to the red conductor on the cable. All right. Tip. Wait, let me get this in a way where you guys can see it well. All right. Tip to red. Good. White to ring. Good. And sleeve to ground. Ha! Okay, good. Good. We got a working cable so far. But now we have to put in the XLR side. Okay. All right, now we're ready for XLR side. What I'm going to do is pop the pins out from this outer housing. This gets screwed on after everything is connected. Goes like that. Ooh. So these XLR, I got to clean up these conductors again. I don't think I'll need extender cables for these. No, I won't need extender cables for these. All right, I'm just... Okay. Ooh, this is really globby. Ooh, you get that smoke going in the other direction. Okay. Yay. Okay. Let's see. Just want to apply a little pressure. Cleaning that up a bit. All right. Ooh. Okay. Just cleaning up the globs of old solder that I have on here. Okay. Cleaned up. Ooh. Watch out. Watch out, iron. Don't burn your own cable. Ooh. Let me move this over just a little bit. Okay. All right, guys. Now, let me bring back the cable. I'm going to start with my ground cable. Now, ground corresponds to pin number 1 on XLR. You want to look very carefully at the pin numbers. Ooh, this stayed hot. All right, so I got to be careful handling this. You want to check the pin numbers that's kind of embossed on the plastic. Find pin number 1 and solder the ground onto that pin. All right, so pin number 1 here is this guy. Let me make sure that I get it on the reverse. That guy. So that's what I'm going to solder onto right now. All right, so here we go. And that's pin number 1. Pin number 1. Gonna bring it together with ground. All right. And I'm just gonna bring there's enough solder on both connector and cable to just bring my iron down on them both and make a joint. Let me heat, guys, a little. Heat. Ooh, come on now. need something really to get pressure down on these guys. Can I conduct through them? Yes. This cable is fatter than the other ones. Might have to make I might have to just apply some solder to bring them together. Not ideal, but since this is the fattest cable, it's not enough. I can't heat one conductor by just heating one, so I gotta make the joint this way. All right. Okay. So my conductors are touching. I'm going to tin the tip of my iron, make sure it's nice and silvery, and heat the joint. Heat the joints, heat the joints. All right, and let me make that neater. All right. Just really want a good connection here. See if I can paint it on. Okay, I think I got it in a good position. Now these guys heat up a little more than the other connectors. I'm gonna let it rest for a few seconds before I try to handle it. Yeah, that's hot. Let's wait a few seconds and then we'll tug on the copper coil and see if we get a good joint. If we don't got a good joint, we gotta do it again. If we do got a good joint, then we can check for continuity. Okay. This is good to handle now. Let's tug on this guy. Okay, I'm pulling, and it seems to be secure. Let's check for continuity. All right, so multimeter, here we go. By the way, you can get a multimeter for cheap, guys, on Amazon. Don't break the bank, just get the cheapest one. It'll do the job for you. That's the continuity setting. Touch your leads together. All right. Now, we're checking the ground, so we're going to place a conductor on the sleeve of my TRS connector, the long part, and I'm going to check the joint here on my XLR conductor. All right, we got continuity. Nice. All right, let's move to conductor number 2, which corresponds to the first signal, internal signal cable on this balance cable. Conductor number 2 is opposite to conductor number 1, so we know it's this one, right? Again, X. If ground is on conductor number 1 and signal 2 is not the middle pin, it's the one opposite to conductor number 1, then that's the one we need to use. This is 1, this is 2. All right, and 2, we're going to use the red cable, which corresponds to the tip conductor here on the TRS. So here we go. Let me set up my helping hands again. And let me see how I'm going to bring these guys together. Okay. Okay. Like so. Okay, so let me set this up and then I'll make sure that I'm in view to you guys. And that's where I want the conductors to connect. Let's see if I can get... Would be so nice if these helping hands were a little more helpful. But let's see if I can hold this on my own, because I don't think I'm going to be able to get the right angle. Maybe this way. See better. Get the white cable out of the way. Okay. I'm going to be very careful with my hands and bring my iron down on those 2 points. Okay. All right, just a little more to reinforce. See if I can paint on a little more. Oops, don't want that. See, it wasn't very secured. Nope, that's not what I want. Okay, got a nice shiny joint. Let's see. Let's give that a moment to cool down before we try to handle it. Okay, yeah, that XLR conductor is hot. Let's give it a second to cool down, and then we'll tug on the joint to make sure it's secure. Okay, it's warm, but I can handle it. All right. So there is my joint. I'm going to pull on it. Pulling on it. Okay, it's not coming off. Let's check for continuity. Now, red conductor or pin 2 corresponds to tip on TRS. So let's go for it. All right. On continuity setting, let's bring the leads together. Got it. All right. I'm going to place one of the leads on my joint, the joint I just made. Try not to touch pin 3, and let's put the other lead on the tip. Okay, got continuity. We can move on. All right, pin number 3, middle pin, corresponds to sleeve, or excuse me, middle pin, pin number 3 corresponds to ring on TRS. So that would be the white cable here, internal white cable. And let's see how to best connect these guys, internally, externally, this way. I'm gonna twist it from the outside. Oh, let me fix this here. This is a globby thing that I didn't see before. Come on. Oh, it's part of the old cable. Let me snip off a part of the old cable that's still connected to pin 3 here. There we go. Now we're ready to solder. Let's see if that's well prepped. Yeah. Okay. So there we go. We're going to get that white cable connected like so. Okay, I'm going to watch out for my hands here. All right. Let me tin this guy with maybe some fresh solder and get some flux on it. With XLR, since there's more plastic insulation on the cable. You don't want to keep the iron on there for too long, because if you melt this insulator, you basically mess up your circuit. So you don't want to do that. Let's get some flux on there. And is this good to touch? Okay, let's get flux on here. And I'm just gonna repin this very carefully. Okay. Now, let's get these two guys together. Ah. You know what? I don't want to be touching that with my hands. Let me see if I can get my helping hands to bring these together. Oops. This is the defective helping hand side. I have to flip it this way. Get these to work like this. Get this down this way. Oop, come on. Pull that way. Okay. Now they are touching without me having to do anything. So let's bring these guys together. Let me reinforce that. Doesn't look secure. No, definitely got to reinforce that. Okay. I don't like that that's globby. There we go. All right, I'm gonna let it cool down for a second. Then we're gonna tug on it to see if we have a good joint. If we have a bad joint, it'll fall off when we try to put the housing back on. All right. Ooh, yeah, let's not handle that. Not just yet. Okay. Okay, it's okay. Let's tug on conductor number 2. I mean, excuse me, conductor number 3. Okay, it seems to be solid on there. None of my conductors are touching each other, which is great. Now, let's check for continuity. So, this is, we're checking ring and the joint between conductor number 3 and the white cable. Here we go. Continuity, setting. And, okay, so let's grab the joint here without touching any of the other joints. Oop, grab the joint and go to the ring. Oops, come on. And we got continuity. Okay, so now it's time to put on the housing, and then we'll check continuity between both connectors. All right, so here you put this guy on first and then screw in the plastic housing. All right, to align it properly for it to go in. So let's find the right alignment. Push, push, push. There we go. Push it until you get the right depth for your XLR male. All right, now attach the housing. Okay, yay. We got an adapter cable. Now let's see if we have a working adapter cable. We're going to check continuity between these pins and these conductors on our TRS. Let's do it. So in your final project, to show that your cable's working, either use a multimeter, as I'm going to do now, to show that it's working, or plug this into something and show me through a level meter or something that it's transmitting signal, however you want to show off how it's working. Multimeter is the easiest because you don't have to have the right things to plug into. It's right here on your desk. Continuity. Here we go. Okay, let's find, okay, pin number 1 corresponds to ground. That's pin number 1, this guy right here. Pin number 1. Oop, come on. Pin number 1 to ground, which is the sleeve on the TRS connector. Oops. Why don't I use my helping hands to help me out with this? Let's do that. Make it easy to see. Why not? There we go. Where's my conductor 1? Where's conductor 1? Okay. This is conductor 1. And I'm going to touch my sleeve. We got continuity. Okay. Opposite to conductor 1 is conductor 2, and that corresponds to tip on TRS. All right, so here we go. Yay, we got continuity. Got transmission. And then pin number 3, which is the middle pin, corresponds to the ring on TRS. Make sure I'm not touching. Yay, we got continuity. Ladies and gentlemen, we got a working male XLR to 1/4 inch male TRS adapter cable. Okay, so this is something that you could do for your final project. Now let's look at option number 2, which is building a contact mic or a piezo electric pickup. All right, so we're going to start first with the basic piezo build. Okay, basic piezo build. So here I have a piezo disc with leads pre-soldered onto the signal ceramic and the grounding brass plate. The leads, I use some speaker cable to extend the leads because I know I'm going to need more length than what came with than the leads that came soldered onto the piezo for the inside of my cigar box guitar. Once I get the cigar box guitar stringed, I'll install the basic piezo pickup to it. We'll make a recording with it, and then we'll take the more complicated build with the piezo preamp built into it. We'll make a recording with that, and then we'll look at a spectroscope to see which of these pickups gives us a richer signal. Now, science tells us that the piezo preamp is supposed to give us a richer signal, supposed to give us back the bass that the impedance issues of the piezo takes away. So we're going to test that theory, at least with this product. We're going to see if this product is actually any good. And again, this is the $3 powered piezo preamp. Well, actually, all of them are powered, that you can buy on eBay. Okay, here we go. So I'm going to connect this guy to a female TS connector. Now, I don't know which of these leads corresponds to signal and ground, so we're going to do a little continuity check to see which lead is which. I'm going to start with the ground. I want to solder the ground first. Back to my continuity setting. Okay, so the ground part of your TS connector touches the inside of this connector. So I'm going to stick that in there, and I'm going to see which of these external leads cause my multimeter to beep. Is it this one? Ha! Okay, let's make sure. It ain't that one, it's this one. Okay, so this is my grounding conductor. I'm going to solder black onto grounding conductor here on my female TS connector. Here we go. All right. All right, let's position ourselves wisely. I gotta prep this cable. All right. Cable is prepped, conductor is not, so I'm gonna do that quickly. There we go. Let's heat conductor a bit. Okay, we're tinned. Now let's bring black cable, our ground, down on this thing. Let me make sure. Let me do it. Okay, sideways. That'll be the best way to connect it. Just thinking about how it's going to lay down inside the guitar. Okay. Okay, I got the two sides touching. Now let's bring the iron down on it. Okay, nice. All right. Let's give it a little tug. Give it a little tug. Now, we're going to check continuity between the joint and inside of the connector, which corresponds to our ground. But to test whether this pickup works, we have to use another setting on our multimeter. I'll show that when we're ready. Okay. Back to continuity for now. And let's check our joint. Okay. I'm going to lay it right on the joint and inside the conductor. Oh, joint. Okay, we got continuity. Now we can do the signal side. Here we go. Let's bring back our helping hands because they're somewhat helpful. Somewhat. All right. And let's grab, I'm going to grab this guy like this. I guess that's okay. No, let's grab it from the ground side. Okay. I'm going to tin this area. Let's put some flux on it. Not too much. These are nice, clean connectors, so it's working easier than the old recycled connectors I was using on the previous demo. Heat, heat, heat a little bit, and there we go. It's tinned. All right, now let's bring cable and conductor together. Let's see if I can get it somewhat aligned like that. That would be cool. Okay. Don't want to have to hold this down, but I guess I'm gonna have to. All right, gonna bring the iron down on this very carefully, watching my hand. Okay, that's not gonna work. I know I'm blocking your view. You guys connect. There we go. Okay. All right, guys. Okay, it's pretty cool to the touch. Let's check for continuity between the joint and this outer plank, which is the signal conductor on the female TS. All right. Back to continuity. Checking. All right, we're gonna touch the joint, and then we're gonna touch the outer plank. Yay! Okay, so this cable and conductor are able to transmit audio. Now we have to see if piezo can actually create audio. All right, so I'm going to set my multimeter to an AC setting. I'm gonna set it to the lowest AC setting. So the lowest, the AC setting here, alternating current, is that symbol V with a tilde next to it. That's what we want to set our multimeter to. Okay. Okay, so I set it to the lowest alternating current setting. Right. And now, it would be nice if I had someone tapping on the table for me while I was trying to make a measurement. But here we go. We're going to connect. The polarity of AC signals doesn't matter, so it doesn't matter which lead you put onto which conductor here, but I'm going to keep it, I want it to correspond, at least for this demo, to the right conductor. So ground and signal. And let's see, can we induce something? I wish I had someone tapping on the table for me. Wait. Can I make it resonate with something? Grr, 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 grr. Okay, I'm getting some reading, but it's not enough to see if it... Okay. Okay. Do I have anything that can create sound? Oh! Duh! Cigar box guitar. Let's tape this on. I'll place my cell phone inside and I'll have it pump up some sound, and let's see if piezo can capture it. Okay. Let's tape piezo onto resonator. Let's take the most resonant part of the instrument, which should be the middle. And let's put my phone blasting some music inside. Here we go. Okay. Pumping that as loud as I can. I'm going to put inside the box. I feel it vibrating, so the piezo should be able to pick up. All right. Here we go. Not getting a reading from my multimeter. Interesting. Do I got a dead piezo? I don't know. Let me check it up here in the joint. Let me check it up at these joints up here. Let me reset my multimeter just to double check. Let me tap on the box, maybe. No reading from my multimeter. May have a dead piezo. Let's see. Let me reset multimeter here. Okay. I'm not getting reading from my piezo at all. Oh no. I know that polarity doesn't matter, but I'm going to switch up the leads here. No. Huh. Well, I'm glad we didn't hook this up to the cigar box guitar, because I'm not getting a reading from the piezo. I checked it from both here and from the original leads that are exposed here. I'm not seeing any of the contacts in contact with each other, so this could be a dead piezo. I want to conduct one more test before I assume that I have a dead piezo. I'm going to try to plug this in and see if I get an audio signal. Just going to grab a cable. Let's see. Oh, wait. We just made a cable that I could plug into one of my XLR inputs here on the interface. Let me just grab that. Our new cable. Okay. Going in here. Chop. And let's see. Input that I'm not using on my interface. You guys might not be able to hear it because I don't have it set up on OBS, but make a quick unplug here. Plugging this into my audio interface and see if I get a signal when I tap on the... Ha 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 ha! I don't know what's going on with my multimeter, but I am getting a signal from piezo. Let me show you. This is the cable we just built that's going from TRS to XLR, although we're only going unbalanced from here to there because it's only using 2 of the conductors on my connector. And so this is where my contact mic is. This is my this is the mic I'm speaking into right now, and this is my contact mic. I'm going to tap on my cigar box guitar, and let's see if we get a signal. Yay, signal! Okay, so we got a working pickup. So week 2, I tinned the tips of all of the conductors on this circuit board. Now we're gonna connect the corresponding inlets to the corresponding parts of our circuit. So the audio in and out on this board are here and here. Here's plus minus on, let's see. All right, see where it says in, plus, minus? The plus corresponds to audio signal, the minus corresponds to audio ground. So we're gonna hook that up to the piezo leads first. That's what we're gonna do first. I'm gonna get a piece of tape because I'm not gonna grab this circuit board with the helping hands. I'll crush one of these small little components and ruin the circuitry. So I'm gonna tape it onto the table and solder straight onto the table. Soldering onto a little tiny circuit board, it's more nerve-wracking to me than making cables, but that's what we're gonna do right now. Okay, so the audio inputs here are prepped. These output cables from the piezo are not prepped, so we're gonna have to do that. The leads on these cables are ridiculously thin. This is like 22 gauge cable. So that's gonna be fun. Let's try it. Let's try it. Let me cut off these ends. We don't need them. Let's start with the signal cable. And okay, popped out. That was a lucky one. Usually takes me a little bit with such small gauges. All right. Okay. There we go. Now we're going to tin the tips so that we're ready to bring it straight down onto our circuit board. All right. Bring back my helping hands for that. Maybe not put it so far away from you guys so you can't see. Again, we're gonna need our flux. You guys can probably guess what's coming next. Flux. And heat the conductors just a bit, just to tin the tips. Ah, let's get this iron. I don't think the iron's up to temp again. Okay, it's going up to temp again. It's up to temp. It's a 740 degrees. Okay. All right. Okay, got a nice tip on there. Come on. Oop, too much. Okay, got a nice tip on there. Now we're ready to carefully bring it down on this, bring these down on the circuit board. You don't want to leave. You're gonna have to heat the board a little tiny bit to bring these guys together, but don't leave your iron on any board for too long, because if you burn through that plastic, your circuit is ruined, probably. Now let's get a little flux. All right. We're gonna start with the plus side. Plus corresponds to signal cable. This is it. Let me align it perfectly with the board. All right, I'm gonna tape that down. Signal cable, you're gonna get secured here. I'm not taking any chances here. I have two boards in case I messed up with this one, but I don't want to have, I want to be able to use that on another guitar. So here we go. I'm not going to apply any new solder. All right. Now we're going to see if that holds. After, okay, I'm going to tug a little bit. Tug, tug, tug. Okay, good. Good. Ah. Good so far. All right, I'm going to do the same thing with the black cable, with the ground. So this goes on the minus input. Now, I'm seeing that there's a possibility that the copper of in and ground can come into contact with each other because it's too long here. So I'm going to snip this down and re-tin it. My scissors. Snip it down so that more insulator is exposed than the copper. Okay, now with this, we're less likely to get the signals touching each other. Okay, but I need to tin that. So quickly, I'll do that. And you guys can guess what's coming next. Flux, flux, flux. Or resin, soldering paste as it's called here. Oh, let's do this. Okay, tip has been tinned. Now let's try to bring it down on the circuit board. Right connector, some more tape, and match this up before I bring the iron down on it. Right there. That's what I want. Right there. Don't move. Oh, it moved. Another piece of tape to make sure it doesn't move. Okay. Right there. absolutely don't want it to come into contact with the signal conductor. So it's scooching over this way. That's not what I want it to do. So, okay, now it's perfectly aligned on the right inlet on the circuit board. So I'm gonna bring this down. It's done. Okay. Let it rest for a second or two, and then we're gonna pull these guys off, tug on it to see if our connections are secure enough. Okay. Let's give it a tug. Okay. Okay, now we gotta set this guy up with a battery pack, a switch, and output leads that will connect to my TS connector. Let's start with the battery pack. Here I have, so this circuit can receive between 3 and 6 volts for power. I have a few of these in my, I guess, electronics junk drawer, and this is a battery pack that takes 3 1.5 volt AAA batteries. So this will give me 4.5 volts of power, so it's within the range of this circuit. Now, the problem is I have to hook this battery pack up to leads, and you have to know which lead is power and which lead is ground. And there's no way of me knowing that because there are no markings on the outside of this battery pack telling me which lead is which. So I'm gonna have to put in some batteries in here and take a reading on my a DC voltage reading on my multimeter. If I get a negative reading, that means I have the leads reversed. If I get a positive reading, then I have, you know, the right leads in the right place. All right, so I'm gonna move this guy out of the way for a second. All right. Okay, so let's get some AAA batteries in here. You want to follow the indicators on the thing. Okay. Yep. Okay, we're gonna set multimeter, and hopefully it won't let us down this time. We're gonna set multimeter to read DC voltage. So it's this one here. The V tilde, that's AC. The V with these straight and dotted lines, that's DC voltage. We're gonna set it to something within the range that can pick up 4.5 volts. All right. Okay, why not the 20 volt setting? Yeah, that should give me full numbers. Okay, again, a negative reading on my multimeter means that I have the leads reversed. Okay. Ground signal. Okay, I do have a negative reading, which means that this is not ground and this is not signal. Let's reverse it. Okay, so I got positive numbers. All right, so that means that this is ground and this is signal. Or power, excuse me, ground and power. So I'm going to put a little dot, a little red dot on the power side, some chalk marker, so that I know which side is signal and which side is ground before I take out my batteries. You must take out the batteries before you try to solder onto this thing. All right, here we go. So that's power. Awesome. Now we know what to do with this battery pack. Okay, multimeter, thank you. I don't know why you didn't work for my AC signal, but that's okay. Okay. So, remove the batteries. Alright. Okay, I'm gonna cut more cable off of this switch. Useful cables here. I wish I had thinner cables for the switch, actually, but I don't. Well, let's see if we can make it work on that board. Alright. Gonna prep my cables. So what I'm planning to do is solder the leads onto the battery pack. One side, and I'm just going to strip all sides. And before I put this together, I also have to plan out my switch. Because I want to install a switch. You don't have to, but I want to install a switch, because if you don't install a switch, if you put in the batteries, the pickup is working and taking up and draining your batteries. So you want to be able to turn your powered circuitry on and off without having to remove the batteries from your battery pack. Okay. All right. Just stripping these cables. Okay. So corresponding to the red dot there, this goes here, that goes here. Now let's plan out the battery. I mean, not the battery, the switch situation. You want the switch to interrupt only one side of your circuit. All right? Make sure it's in the off position when you're working with it, and then put in the batteries. I'm going to have it interrupt the ground position. Okay? You don't want to interconnect both sides. No, no, no. That will not shut your circuit off. In fact, if you do this, your batteries are going to get hot and they're going to explode. So, how this is going to work is, switch is going to interrupt the ground side. Then the lead on the switch will be connected to the ground on the VCC inputs on your circuit board, which is the power. And the signal will get soldered to the power on its own. Now, after you put this together, guys, you want to turn it on. I mean, when you, in regards to hooking it up to the board. After this is hooked up to the board, you want to turn it on, and you want to wait a minute and see if your battery is getting hot. If your battery is getting hot, you've connected something incorrectly in regards to the battery pack or the switch. In that case, remove your batteries immediately before they become too hot to handle, and they will heat up very quickly. So if after a minute your batteries do not get hot, you're good to go. Okay? All right, let's prep the leads on this rocker switch. Simple rocker switch. And I know that I have electrical tape, something that I want to go over all of my joints here. I think I have some electrical tape accessible right now in my toolkit. Let me see. And I forgot to take it out. Interesting. I thought I had electrical tape in here. How about... I knew that I had electrical tape somewhere. I'm going to want to close these up once I see that my batteries are not going to get hot. Just to protect my joints a bit. Okay. All right. Let's apply flux to all of these connectors. All of these conductors, excuse me. First the battery packs, then the battery pack leads on both sides. Thank you for sticking with me so long, guys. You guys are really dedicated. That's awesome. All right, and you'll be ready to go for your final project if you choose to do one of these things that we're doing today, that we did today. All right, now let's prep all of this stuff. We're going to tin everything. Ooh. Okay. We're going to tin the tips on this battery pack. All right. So much going on this table. Ooh. Let's see. Let's put all of that over there. All right, soldering iron's a little bit dull, and it's coming up to temp, so there it is. Okay, let's heat this a little. All right, a nice bulbous thing there. Gotta heat this. Gotta heat this better. Okay. All right. Tin the tips on battery pack. Let's tin the tips on battery pack leads, which are these guys. All right. Heat them up a little. Heat, 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 heat. Oh, come on. There we go. 1. Heat, heat, heat. Heat up. 2. Next. Heat up a little bit. 3. And on this side, heat, heat, heat. 4. Okay, those are tinned. Let's tin the leads on the rocker switch. Let's make sure these are small. Get them as compact as possible because one side goes onto the little circuit board. All right, heating up these guys. Heat, 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 heat. Next, there we go. Other side. Oop, there we go. Heating, heating, heating. All right, looks good. Okay, now let's connect all of these guys together. Okay, battery pack to leads. Let's see what would be the easiest way. Let's start with the signal side. Side with the red dot. Signal to signal. I'm gonna get them as close as possible and bring my iron down on the conductors there. Okay. Okay, that's nice. Maybe a little more. Alright, good. And we'll check by pulling on that. Okay, it's pretty cool to the touch. Good, good. Okay, now let's do the ground side. Let's bring both conductors together. Let's do it like that. No. All right, let's see if I can get that to work. Heat the joint, heat the joint. I'm bringing in some. All right. Oop, drip on the bottom. There we go. Okay, let's tug on that and see if we got a good connection. That's pretty good. It's pretty good. All right, now next we're going to connect the switch to interrupt. Excuse me. We're going to connect. We're going to use the switch to interrupt the ground side. So again, here's battery pack. Signal, ground. We're going to interrupt the ground side. Okay. In fact, I'll tape these two together and just bring my iron down on it. How about that? All right. I should be able to just bring my iron down on that. Let's tint the iron tip a little more. Get it flowing. All right. Perfect. All right, we'll tug on that a little bit to make sure it's secure. Okay, are we secure? Yeah, pretty secure. Let's grab the other side, why not? Seeing that the other side is pretty bare. Bring it down on the other side. Not for too long, however. Ah. I ruined my joint. There we go. Now it's flat, like it was before, and I got it on both sides just because I wanted to see both sides tint. Okay, now that is secure. I feel good about that. Okay, so again. Oh. Crap. I ended up, I don't know if you guys noticed, I ended up interrupting the power side. Well, that's okay. I usually, you know, just like to interrupt the ground side, but I interrupted the power side, but that's okay. The point is, you interrupt one side only. You do not create a loop between the battery pack and your switch. Again, so now this is the ground lead that's going to connect to the circuit, and this is the power lead that's going to connect to the circuit. So here we go. Let's bring our little circuit board back. These cables are, these look like 18 gauge cables. I hope they're not too big for a little circuit board. We'll find out. Okay. All right, and we're going to begin. We're going to prep again by taping our circuit board straight onto the table. I'm not going to use the helping hands on this one. Let's just tape my component onto the table. And I'm going to move these guys out of the way, so they do not interrupt my work here. Okay, so I moved piezo leads out of the way. All right. Let's get, so here is, well, I should have showed you. It says VCC. Your VCC plus and minus inputs, that's for your battery. All right. VCC plus will receive red side. VCC minus will receive black side, the ground. Let's start with the grounds. I should have moved these cables over the other way. All right. So I'm going to tape that straight down onto the circuit board and just bring my iron down on it like I did last time. And these cables look kind of fat for the board. Let's see if I can get it to connect anyway. Here we go. That's barely on there. Let me tug on it a little bit. Maybe it looks like it's barely on there, but it's secure. Let me see. Oh no. It's pretty secure. It's secure. Okay, good. All right, now on the power side. You know what? I'm gonna just get electrical tape on there now. It bothers me to see that joint there. Okay, now let's see if well, that's what happens when you have one lead slightly longer than the other one. Okay, I'm going to tape that right there. Actually, I'm going to make the power lead shorter to make doubly sure, again, that it doesn't come into contact with the ground lead. So I'm going to tin the very, very tip of this cable here quickly. Alright, I applied a little bit of solder, and now I can bring it down onto the power input. No, maybe I want to tape it down. In trying to do things fast, I can mess things up, so I'm not going to do that. Get it down like there. Okay, now that's positioned exactly where I want it. There. Now let's bring the iron down on it. Let's make this iron tip shiny, make sure it's hot. And here we go. Okay, that looks secure. Let's give it a moment to settle, cool down, and now let's pull on it, tug on it. Okay, that's secured to the board. Good. All right, so now, okay, before we commence to connect the audio output of this board to our TS connector, we want to put in the batteries and check to see if they get hot. If they get hot when I flip on this switch, I'm going to have to remove the batteries quickly and troubleshoot and find out why the batteries are getting hot. It could be that I have something wired incorrectly between the battery pack and the board. We don't know. So let's test this first. And if you guys decide to add a piezo preamp with a switch into your project, you're going to want to conduct this test. All right. Okay, I'm going to check that my battery pack is off. Yeah, it's in the 0 position. It's off. Wait. Ah, okay. This was not secure. Let's do it again. There's some there, some flux there. Okay. All right, let's match that up again. Let's get that exactly on there. These leads are so much fatter than the inputs on this board. But we're going to try it anyway. We got the ground to stick. Let's try to get the signal to stick. Oh gosh. Okay, stay on the board. Stay on the board. Okay, I'm going to put the iron away because I don't want to burn my hands. And I'm going to tape down that lead so I don't have to hold it in place at all. Okay, okay, now I'm properly aligned. Here we go. Wait, this is not silvery. Make sure that we're hot enough on the onset. I don't want to use more solder because then I'll come into contact with the other connector, and I do not want that. But I might have to bring some extra solder to the party here. Let me make sure I'm properly set up here. Put iron down. Bring solder in. Okay. Alright, that looks secure. Let's try it again. Let's tug on this and see if it'll disconnect on me. Pulling. Okay. It seems more secure. Hopefully I'm right this time. Okay. Battery pack is off. I mean, switch is in the off position. Let's put in our batteries and feel the batteries. Make sure they don't get hot. Okay, we'll leave it in the off position for a second or two. I don't feel any heat. Okay, let's turn it on. Switching battery pack on. You want to conduct this test every time you set up powered circuitry with the switch. I'll just give it a few more seconds to make sure we are safe to go. Okay. I'm pretty sure that this is not going to get hot. It would be really hot by now if it was going to get hot. So I'm going to go ahead and turn this off. I'm going to remove the batteries before I proceed to solder the output cables onto this board, and then, well, first I'm going to solder the output cables onto my TS connector, and then I'm going to solder the leads from the TS connector onto the audio outs on this board. It says out, plus minus, plus signal, minus ground. Let's prep the output cable, and then let's prep the connector, bring them together, and attach them to the board. Here we go. Again, I'm using speaker cable because that's the only copper cable that I have available to use. Everything else is aluminum for my DMX builds. DMX data cables are for lighting systems. All right, so I'm just unsheathing. And let's do some more unsheathing. All right. Okay, let's do unsheathing of this side. Yeah, I'm definitely faster with these wire cutters than with the wire stripper I had. It could be that the cheap wire stripper I have isn't very good. Alright, so we'll give that a twist. Now we're ready to tin our output cable. Here we go, tinning our output cable. Let's bring helping hands back into the game here. Soldering iron is on like a resting setting. You guys know what's next. We need our flux before we tin the tips. And wake up iron. See, I've taken you out of your holster. Okay. Let's heat our tip here. Okay, nicely tinned tip here. Heat. Okay, now we gotta do the other side. Oh, let's twist these strands together again. Okay. You guys guessed it, flux. And let's get going on that. Let's heat. All right. Heat. Okay. There we go. Oop. Too much solder on there. All right. Okay, now we gotta tin the connector. We've already prepped the output on our board. Okay, so again with this TS connector, I don't exactly know which one is signal and which one is ground, so we have to bring our multimeter in again. To check on that, we're going to set it to continuity. All right, let's find out where the ground is, and that'll tell us where both is. So I'm gonna insert that and see which lead is ground. Okay, it's this lead. See this one? No sound. This one, sound. So that is our ground lead. Or our ground conductor, excuse me. There are no leads on it yet. We're gonna attach leads to it now. Here we go. And so, I'm gonna grab it this way. Let's add some flux to the surface of that. Okay. And let's heat up the element a little bit. Heat, 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 heat. All right. Okay, so that's our ground. Since we know that's ground, let's attach the ground to it. Let's bring them together. All right. And so I'm gonna bring the iron down on this guy. Here we go, very carefully. There we go. All right, that looks pretty secure. Okay, it's safe to handle. So I'll unclip it and tug. Let's check for continuity. I know, it's a long and tedious process, but you want to be checking things throughout, so if something goes wrong later, do the troubleshooting as early as possible. Okay, ground. Okay, we're conducting. So good so far. All right, let's get the signal lead onto the signal conductor on the TS connector. Wait, I have to tin this. I have to tin the tip of the TS connector. Forgot about that. Okay. Let's get some flux on this guy. There we go. All right, we're gonna heat this guy and apply our solder. Awesome, there we go. Now that we're here, let's get signal connected to signal. Something like that. Come on. Come on, helping hands. Okay. I'm gonna very carefully bring the iron down on that. All right. I'm gonna wait for it to cool, then I'll tug on it, check for continuity, and then we're ready to connect our output leads to the board. Yep. The dangerous part, because these cables are really fat. 18 gauge cables. That's all I have. We'll make it work if we can. All right, here we go. Okay, seems pretty solid. Let's check for continuity. Signal to signal. All right, signal on our TS connector is this long plate here. This is the signal plate, this long plate. Gonna grab that. Gonna go to the red end of the red wire here. Okay, we got continuity, so this is a working connector and cable. Let's hook it up to our board, and then we can test this pickup, this buffered piezo pickup, which should give us a better frequency response than just the piezo alone. All right, let me reorient this. And you see the last leads we're going to solder onto, that's our audio output. Let me bring it closer so it's more in frame. There we go. Make sure all of this stuff is out of the way. Okay, scary part. Plus to plus on here, minus or ground to minus. Here we go. Let's bring this somewhat into place, and then we'll bring it into place. There we go. All right, it's positioned exactly where I want it on the board. Now, the moment of truth, here we go. All right. Okay, give it a moment, cool down, and let's tug on it to make sure it is secure. I'm going to shorten the ground lead. Okay, pretty secure. I'm going to shave a bit off the end of this ground lead because by shortening the lead, it kind of ensures that the signal and the ground don't ever come in contact on the board when I'm finagling with this inside of my cigar box guitar. So let me trim this a bit, and I'll have to retin it, unfortunately, but it's worth the effort. Yeah, definitely worth the effort. Okay, you know what comes next? Flux. And here's my solder. Alright, iron. You're looking a little dull. Let's heat this guy up. Okay, that's tinned. Now let's get it down. Let's position our ground down on. That's precisely where I want it. So I'm gonna just bring my iron down on that. All right, let's give it a moment and then check to see if it's secure. Whoa, if it's secure, we can turn this thing on after we put in the batteries, and we can check to see if the batteries get hot again. Just doing that battery check again, and then we'll check to see if we actually get a signal from this thing. Okay, I think that's enough time. Cool beans. Oh, it's looking good so far. Okay, test time. Let's put the batteries back in. Well, battery test time. And then we'll do the real test with my cigar box guitar's resonator. Hey, don't slip out, batteries. Okay, let's turn the switch on. Ooh. Okay. Gotta check the batteries. Make sure nothing is interfering with itself. Let's give it a few moments. You want to be checking periodically because you don't want to arrive when the battery is already so hot that you cannot handle it. we seem to be okay. Okay, I'm going to turn this off. Let's get the cigar box guitar and do the journey test again. All right, so I'm going to place this guy. This guy will go on the guitar for now. We're going to tape piezo onto somewhere on the body of the guitar. Okay, we'll tape down battery pack so it isn't moving around when I'm opening and closing the lid. Let's take the adapter cable that I built earlier. I'm going to plug into my female TS connector, and then I'm going to plug in the XLR into a mic input on my audio interface, because that's what I have available. Okay. Right now, no signal. We should not be getting a signal because, interesting, I'm getting a signal even when the preamp is off. The piezo preamp is off. All right, let's turn it on. Okay, I'm getting an audio signal. Let me show you. Oh, and it seems to be hotter than the. So this is piezo, input number 2. Nice. Okay. Okay. I'm going to turn off my circuit. Ladies and gentlemen, we have a working buffered piezo pickup. This pickup should improve the frequency response of our piezo. Again, we're going to make a recording with the guitar once I have it all stringed up. We're going to compare this guy to the basic piezo pickup and see which one sounds better, which one gives us a richer sound. And of course, we know that this should give us a richer sound, but we're actually going to put this product to the test.